Share the whole. Well, I'll wait to share. We got a few people popping in. We're gonna wait just a couple minutes, give everybody a few minutes to join, and then we'll get started. Wait till 5:03. Oh, man. Jim Gapley is on this call. I'm sorry, Jim. This is not gonna be as good as your session. We're sorry. One more minute. Got a lot of content to cover today, and I think it's already 5 o'clock, 6 o'clock for some of you maybe. I'm gonna hurry this up, get to dinner. Okay, it is 5:03, so let's go. We got a lot of people in the meeting now. I'm gonna share my screen just to share a little bit of content here today. And I'm sharing the whole screen. I'm just gonna leave it like this, and hopefully you guys can see this. So what we're gonna be talking about today is how to design and manufacture a printed circuit board that you design yourself and then you get manufactured through some of these online services. So there's a lot of people who probably don't realize that this is something that they can do. And it's actually not extremely difficult. Let me introduce myself real quick first. My name is Dave. I am one of the senior cloud architects here at Fulcrum. I've been here about 8.5 years. And so I'm also the manager of the cloud team. So we do a lot of work with Azure, AWS, a lot of work in the automation space. So if you guys have any interest in that and need some help with that, let us know. We can help you out. So this session is a little different than what we've done in the past. I think in previous FCons that we've done, we've always kind of done a session on soldering, specifically around soldering and electronics. And in the past, you know, in the kits that we would send everybody, we would send soldering irons and some solder and that kind of stuff. And we felt like, well, we've done enough of these FCons and we've sent enough soldering irons that we didn't want to do it again and send more soldering irons out to everybody. So in this instance, what we chose to do was to send you a kit, and I'm gonna show you all this kit real quick. I don't know if you guys got this Can you even see that with the weird? Okay, there we go. This kit right here. So if you got that, and you open this thing up and look inside, there is so many cool, neat things that are in here. Basically, what I did was, when I saw this, I wanted to have one of these kits really bad. So, basically what I did is I tricked Fulcrum into buying me one of these kits by providing it to all of you, in the session. So if you look in here in this kit, there are at least 40 different projects that you can do in this kit. There's an Arduino in here. There's all kinds of like servo motors. There's a fan. There's little speakers. There are little display boards. There's thumbsticks in here. I mean, it is crazy. You can do tons and tons of stuff in here with this kit. Yeah, okay. So anyways, what you need out of the kit today is just the breadboard, and I'm going to show you this on my document camera. So I'm going to stop sharing. No, I'm going to keep sharing. I'm going to change my camera to my document camera. Sorry, this is going to not look good for just a second.
Oh, it's on the screen.
Yeah, I'm switching to my document camera right there. There you go. So okay, so what you need in this course, and we're gonna try to do a little bit of hands-on, but really we're gonna have to go pretty fast to get through all this content. But what you'll need in this course is the breadboard that came out of there, and then there was another little envelope that we presented or put in the kit, and that was, what the heck? Sure. So what the other thing that we put into the kit was a little circuit board right there. So if you find that, that's in there. And so what we originally started to do with this session was we were going to do soldering again. And so I thought, well, wouldn't it be really cool if we could create like a printed circuit board that was in the triangular shape and then had the Fulcrum logo on there. And so we did all that and made this thing and made it work. And then all of a sudden I thought, well, wait, wouldn't it be actually kind of cool to show that whole process that we went through to actually create the circuit board? So how do you design it? How do you test it? How do you manufacture it? And so we're going to go through that whole process today. And if we have some time, maybe we'll do some soldering on here and see if it works. So, so we got the circuit board over here. Some of the other things are in the kit. There's a little power connector that you would need to make this thing work. Let's just grab this. There's some LEDs. See if we can slide those in there. There's some LEDs in that kit. There is, slide this over. There are 4 resistors that are in this kit. And then I think there's also a 9-volt little battery connector that we're going to use in here. So those are the things that to make this work today, you would probably need to pull out your kit. We're going to go so fast that you probably may or may not be able to follow along. And if you can't, I'm sorry about that. But what I would like to do is kind of start out by saying, okay, the first thing that we have to do to design our board is come up with what our requirements are. So in this particular case, I knew that I wanted my circuit board to be a triangular shape. I knew that I wanted to have the Fulcrum logo in there on the silk screen. I decided that I wanted to have, 8 LEDs. I decided that I wanted to put those LEDs kind of in a pattern on the F. And then also that I wanted to use a 9-volt battery. And the reason why I chose a 9-volt battery was because I just thought that that's simpler to use, for a demo or for somebody that's trying to do this at home. It's very, very simple to connect a 9-volt battery. So that's kind of where I started with my requirements. And so the next thing that we have to do is we have to take that and build that into a program that lets us create a schematic. So I'm gonna resume my screen sharing, and I'm gonna pull up this particular application. And if this is not visible to everyone, somebody ping me on Teams and let me know, and I'll try to reshare. But this application is called Easy EDA. And this is very simple to go get. You can go to Google. You can Google Easy EDA and takes you right to their website, and you can click downloads. And there are two versions of this that you can download. There's the there is the standard version, and then there is the professional version of this. So what I would recommend is you download the standard version. That's what I'm using here. And so once you've downloaded and installed it, basically what we do is we go File, New Project, and it will ask you to give it a project name. And so you would just put a project in here, and then it would open up this window right here. So I'm doing all this live. I'm going to try to build this thing live while we're doing this. And so, you know, chances are something's not going to go correct, but that's okay. So in order to get where I wanted to get to, the very first thing I needed was a way to connect power to this thing. And there's lots of videos on this on YouTube if you guys want to do this, but typically in a circuit design, you know, we're going to have a ground, and then we're going to have power. I'm going to make this a little bigger. How about that? And so I wanted to connect that to to a very easy to use terminal block that would be simple for everyone at home to kind of, you know, you only have to solder two things, and then you can stick the wires in there and screw the screws down, and be very simple to do. And so I Googled around for 2-pin terminal blocks, and I found the one that was included in your kit. And then what you do is, as you're searching around, you find these electronic components. You can usually get the part numbers for them. And so I wrote this down. So this power connector is a KF301. And so we're going to go into the library and we'll search for that. And so this application, Easy EDA, comes with a library that has almost any part in the world is in here, and you can find it. So once I've found it, you can see it actually shows me a little picture of it, so I know that that's the right thing that I wanted. And I'll click place on here. And that gives me, in my schematic, the power connector that we're going to connect to. And then the other thing that I had said that I wanted was some LEDs. And so I searched around on the internet and found the part number for an LED. And what I really wanted was a white LED. They're all different colors, as you know. There's red, you know, yellow, green, blue, and white. I chose white. That was just one of my requirements. And so I found a little part number for an LED. Paste that in. And we'll place this on our schematic. So I'll put that right there. Now, for me, that's going the wrong way. So I will just do a little thing. Whoa, it moved the whole thing down to the bottom of the screen. That's cool. So now I've got it kind of going the way that I want. And so the easiest thing right now to do is just copy and then paste that everywhere I want it to go. Get rid of that. So right click on that, copy, paste. Probably can do Control V. And there we go. I need 8 of these things, right? I know this looks all hard and complicated. What I will tell you is that when I started doing this about 4 years ago, I had no idea how to do any of this. My goal was to try to build a simulator for Microsoft Flight Simulator. And I decided that I wanted to put LEDs on there and have all kinds of buttons. So that's how I kind of learned all of this. And really learned it all just by watching YouTube videos and reading blogs and that kind of thing. So I am not an expert at this by any means. And And if I can do it, you can do it for sure. So one thing about LEDs is that if I were to just kind of connect the circuit up this way and then pass a 9-volt battery through it, or put a 9-volt battery, that would send so much current through these LEDs that it would basically pop them and they would burn out super quick. It's actually very anticlimactic when that happens. They just kind of glow for a second and then they go out. There's no pop, there's no smoke. It's kind of boring. But we don't want these things to get burned out. We want to just have them come on and glow. So in a typical circuit with LED, what we want to do is put a resistor in line with our LEDs, so it will reduce the current that's flowing through there to a level that the LEDs were designed for. And that's a whole another class that you could do, is how do you figure out, what resistor you need for the LED based on the voltage that you're sending through. It's something you can Google. You can Google resistors for LEDs, and there's calculators out there that let you figure this out. But what we figured out was we needed the 110 ohms. But as far as the schematic goes, I just need to paste a resistor in here and put it in line. So I found one of those. I'm just going to copy that. Go back into my library. Paste that in. There it is. And I'm just going to place it right here. There's probably some electrical engineers out there that are watching me and they're screaming at me right now. Thank goodness they're muted. So I got those in line now. And what I have to do is then I have to connect all this up, right? So there's a button up here that says wire. So we're going to click that, and then we're going to connect all of this up, point to point. I need this point connected here. And then from here, I've got to connect all of these things up the way that I want them to go. So this is going to connect there. I'm going to connect this here. I'm going to connect this here. And I'm going to connect this here. And then from here to here. Well, not that. So what you can see that I'm doing is I'm doing this where there are actually four rows that are in parallel with each other, and then there's 2 LEDs that are in what we would call in serial with each other. And so the reason why I chose to do it this way was because if you're a beginner at soldering and you mess something up or put something in backwards, you'll have 4 different chances to make this work. So if you screwed something up in any one of these paths, you still got another chance to get it right. So maybe some of your LEDs will light up, even if you make a mistake. So we got that. And then now I need to connect all of these things back to the ground terminal. Whoa. Sorry, trying to do this live. It's crazy. Let's see. So we'll just connect. Man, what the heck? Okay. Guess I can't do that. Yeah. Told you this would be something goofy. We'll make it work. Here we go. Just trying to connect all of the negative sides to back into here. And then I got to connect this into the ground. Okay. So that is the one second. Okay, so there we go. All right, so basically now I have like these four parallel parts of the circuit, each with 2 LEDs and a resistor in there. So that's kind of like step 1, right? So we defined our requirements. We kind of drew it out in a schematic. We found different part numbers that we wanted to use. And so the next thing that we would typically do in a situation like this is that we would breadboard this out to make sure that this would actually work. And so I'm going to try to do that over here on the document camera. Let's just see what happens. Yeah, let's just move some things out of the way. Move this out of the way. That out of there. All right, so let's bring this in here. And this is our breadboard, right? So some of us, it may be a little hard to see. It's kind of hard to zoom in with this camera. But this is a breadboard, and this is typically what you use to mock up circuits so you can test whether they work or not. So if you're familiar with breadboards, you know, that's fine. But if you've never used a breadboard before, it's a little confusing how these things work. So if you look at it, what you have is across the top, you have a little pointer here. Across the top right here, you have a red line, and then next to that, you have a blue line. The red line is labeled positive. The blue line is labeled negative. And the way that it works on a breadboard is every pin on this entire line along the red line is connected. And the same for the blue line. Every single line on the blue line is connected. And then you provide power to it. And so what I've done is I've basically just took that 9-volt battery connector that was in your kit, and I plugged the red into positive, and I plugged the blue into the negative, and I got my 9-volt battery attached to it. And then if you look at all of the channels this way, they're labeled A, B, C, D, A, B, C, D, E. All of those are connected this way. Those are not connected this way. They're connected this way. And so all 5 of the little pinholes on that channel are connected together. And then all of these on this side are connected together, but these are not connected to these, right? So these are separate from these, but these are all connected together. So a little confusing at first if you've never used a breadboard. But what this allows me to do is that I can plug something in to the, let's see if I can just do this live. I have a whole pile of little things over here. Let's just see. So if you look at my schematic that I drew, it's basically showing that from the positive, I have a resistor that goes in and connects to an LED. So we'll just plug in a resistor anywhere on the red line. Plug in a resistor, and then plug it into one of the holes in the little channel. So that's step 1, right? The next thing that we have in the circuit design is putting an LED. And so a couple of things about electronics here. A resistor, there is no positive and negative to a resistor. You can put that in any direction you want. But LEDs are a little different in that there is a positive and a negative. And so in the diagram, I've shown that the power flows this way. So this would be positive and negative side. And when you look at an LED, if we can see this, the way that you can tell the positive and negative side is that the positive will always be slightly longer than the other side. So now I can tell you which side is positive and which side is negative. So according to my schematic, I need to plug the positive side in along with that resistor. And so I'll plug that in. And then what I'll do, I'll plug it into that same line that the resistor is in. And then I'm going to plug it into somewhere else, into a different line on here. It's a little hard to see in the document camera, but you would plug that in there. And then in the schematic, we've got a second LED. So the negative side of the LED has to connect to the positive side here. And then the other side of that would go to the ground channel. So theoretically, if I plug this in there and there, it should light up. Okay, great. So we've got it. So that is the basics of like one of the channels. So to test this out the rest of the way, all we'd have to do is do this 3 more times. I'm gonna unplug this just temporarily because it's just too bright. But we'll take the other 3 resistors that are in the kit, and we'll just do the same thing. Red to a channel for the resistor. We're gonna put in the positive side. I bent it a little bit, you can see, so that it'll fit properly in the breadboard. Run that over to another channel. Take the positive side of that channel and run it to the negative. That should light up. It does. We're good. We'll do this again with another resistor. Let's see. Same thing, another LED. Put that in there. And then finally, one more over here. Go here. Plug that in. Hopefully I'm still on the camera. And then kind of our final LED here. And so now I can put the rest of them in and blind you all on the camera. So there's 1, there's 2. My other ones have disappeared. So I'll grab some more. Oh, here they are. And got that going. And then our final one is there. So at this point, let's see. Something loose on my breadboard. Doesn't want to work. I've got it going in the wrong hole. How about that? Oh, well, not working. See if we can get some different LEDs in here real quick. We do a quick troubleshooting. Doesn't work, no big deal. We'll move on. This is a live demo, and live demo always has something that chooses not to work. So boop, boop, boop. Okay. So good chance that I probably blew one of my LEDs out by putting it in backwards or something. So, okay. So now at this point, we've decided that our circuit works. And so we're pretty pleased with it. It does what we want it to do. It lights up, all the LEDs light up, they don't burn out. I think we're good. So what we want to do now is we want to turn this into a printed circuit board, a PCB. So in this application, Easy EDA, we go up to design and we can convert the schematic to a PCB. So let's just do that. Oh, please save. Or are you doing? No, let's just say, great. Design, convert to a PCB, and I'll just accept the defaults here on the size of the board, because we're going to adjust all of this to make it look more like we want to. So we'll just apply that. So here we go. What you see here is you have a rectangle. This represents the outline of the circuit board. And then it puts all of the parts down here, connect it all up. And then now it's up to you to decide where you wanted to put them. So if you remember, our requirements were to have the Fulcrum logo, a pyramid shape, and then have all of the LEDs laid out where we wanted them. So what I'll do is I'm going to go to what's called the top silk layer. So a printed circuit board has a top layer, has a bottom layer, there's a top silk layer, and then there's a bottom silk layer as well. And that's just in a very simplistic way to look at it. I think there's circuit boards now with like 16 layers and all kinds of crazy stuff, but I'm not nearly enough good enough to do any of that stuff. So what I'm going to do is I'm going to flip over to the top silk layer, because the silk layer is where you put all of your graphics, you put all of your words. So if you have instructions for the user, you can type them there and put them on the silk screen layer. You can label everything like LED 1, 2, 3, 4, as you see here. That would all go on the silk layer. So if I want to place an image, I go to the silk layer and then I can import an image. I'll select an image file, and I think it's this one. And if I open that up, you can see that that is the Fulcrum logo, and we punched a bunch of holes into it. So I'm going to import that in, and There it is. It's huge. It looks huge, but it's really not that big. So now I have that, and what I would like to do is let's move it around just a little bit. I want to start getting this shape to go around it in the pyramid shape. So I'm just going to drag that around there, drag that down there, drag this over here. If I can get it, put this up. Whoop, 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 whoop. Put this up here. Now this is really going to be terrible. Let's just say my the one that we sent y'all was done way better than this. This is me trying to do this in a live demo. In fact, let's make it look kind of wonky shaped, right? Why not? We're not going to get it right, so let's just make some really weird shape, something like that. Okay, so we got our pyramid shape that we drew around it, and then what we have to do is place all of these items on the board where we want them to go. So I've got the holes, so obviously that's where the LEDs are going to go. Oops. Sorry, let's switch to the top layer, edit that. And then I'm going to drag the LEDs to all these little holes. There we go. There we go. There we go. Normally I would probably try to match these things up with the channel that they're in, but for this, I'm just kind of shoving them all over the place. Let's move this thing kind of right here. And then I've got to replace my place my resistors. So I'm just going to jam them all in here. Okay. All right. Oops, I accidentally moved that way up there. Come back. Okay, there we go. So we have that placed on our board. And the one thing you might notice pretty quickly is it looks like a spaghetti mess of lines going everywhere. So one of the things, best practices that you could do would be to, place these things to where you don't have a lot of crossover in your lines. I'm not going to do that for this. I'm just going to leave it the way it is. But as of right now, none of these components are actually connected to each other. All the blue lines are showing you is how they would be connected based on the schematic. But one of the things you have to do is create the routes between all of the components on there. And so what I do, I just keep it simple. I like to use the auto router function. There are some people that would say that's a terrible thing. The auto router is terrible. Maybe it is, but for me, it's always worked pretty well. And I'm not good enough at this to do all my own routing. So I pretty much go to route and I do auto route. And we can leave this the way it is. I do not have the local auto router installed because that's a pain in the butt. So I just leave it cloud and we'll run it. And so it's telling me that it made 26 connections, 100% complete, 0 failures. So that looks pretty good to me. So now you can see that what it did is it converted all of those blue lines that are all over the place now to really nice little lines that go to each one of the connections that it needs to connect to. So I think that we're all good for that. So this is like really at this point, we're like 90% done. We've got it all kind of laid out the way we want it. We have our logo on there. But one of the cool things that I like about this particular program is that now I can sort of visualize what it looks like. I can come up here and click on the 3D button, and it will generate a 3-dimensional view of my circuit board. So now I can kind of see what it looks like. So, hey, the cool thing is it looks kind of like a mountain. It's not a triangle, but it's kind of artsy in a way. So we'll leave it. Well, let's just leave it like that. But you can see all our components on there. There's our resistors. There's our LEDs. There's our power connector that we're going to use. Looks very similar to what we provided in the kit. And so let's say we're good. We want to manufacture this thing. We want to have it printed. So what we'll do is we have to export it out from here. We have to export it out into a format that all the manufacturers understand. And so that particular format is called the Gerber format. And Gerber format is really just a zip file that has, a bunch of files in it that describe this entire circuit board to the manufacturers so that they know how to produce it. So I'm going to hit save button up here. And I'm going to export this out. So if we go to fabrication, you'll see there's an option here for PCB fabrication Gerber file. So let's click that. And it always wants to run a design rule check just to make sure you're okay. So let's do that. You can see the design rule check came back with 0 errors. So it says I'm good to go. So that's nice. And so what I'll do is I will generate the Gerber file. We'll just save that here. And so now, as far as easy EDA goes, we're pretty much done here. We've designed a circuit. We took a look at it. We tested it with the DRC. Everything checked out. We've exported it out as a Gerber file. So now we could actually go and get it manufactured. So there are a lot of manufacturers. I say a lot. There's several manufacturers that will do this for you. And the one that I have always used is JLC PCB. This is the one that I've always gone to. They're very easy to upload your files to and purchase. So if you go to their website, right off the bat, you'll see this button right here, Add Gerber File. So all we have to do is click that, and we choose our Gerber file. Let's open it, and it's going to process that for us. We'll let that finish. And we kind of get to see what our Fulcrum mountain looks like. So we know we uploaded the right thing. And then there's a whole bunch of options in here for your circuit boards. I'll be honest, I'm not good enough to really get into all this stuff. So I kind of leave things basic. The FR4, that's the traditional base material. We have 2 layers. The PCB quantity here is 5. The minimum that you can order at any time from them is 5. And so some of the things that you can control here, like if I wanted to change that to blue, now it's a blue background. All the ones that are in your kit are green. The reason why is because it takes 2 days longer to produce a blue one than it does a green one, and I was in a hurry, so I chose green. But you can pick kind of different colors depending on your needs. You can change that. We're just going to switch it back to green. And all of this stuff, I almost always just leave exactly the way it is. I don't change any of the settings here. And I hate to say it, but that's it. So I save this to my cart. And of course, they want me to sign in. And so if you go to JLC PCB, if you actually do want to order a circuit board from them, you just have to create an account. But don't use any password that you've ever used anywhere else ever, because let's just say JLC PCB is in a foreign country and they're probably being snooped upon. So, make up a new password. So here's what you can see. We'll minimize this out of the way. So basically the engineering fee, $4, surface finishing, the board is $2.60. The build time's 2 days. If you want it to go faster, you can pay extra money. And then there's a shipping estimate. So what I always thought was funny about this is that the boards themselves are only $7, but to get them shipped is $18. So it's way more to ship them than it actually is to make them. So really, like, the step is, we save it to the cart, you check out, and you're done. And so it's kind of interesting. JLC PCB will show you the progress of it as it goes through the process, so you can actually see it, going through. They'll do a design check on it to make sure it works. And then from there, they'll go to manufacturing. And then when it ships, you'll get a notification. And then a few days later, your boards will show up. And if you like them, you test them and they work, you can come back here and then you can order more. So I had to go through that process for this session. I had to order 5 of them, get them, prototype basically. And then to be able to order more than 5 at a time, I had to order the 5 and then verify that they're tested correctly. And then they would allow me to purchase more. So I purchased about 250 of these for this class today. But that was it. So really, it seems complicated. There is probably the biggest learning curve here is learning Easy EDA. But it's a free program. You download it. There's a lot of videos on YouTube on going through and how to do it. And then probably the second hardest part is just finding all the components that you want to use, because I'm not a electrical engineer. I didn't know anything about electronics when I started doing this. I kind of just had to figure it all out on my own. Don't know if I'm doing it right or not, to be honest. But hey, I put it on my breadboard and it worked. So there you go. So that's that. That is literally the whole process of how you would design, test, and then get your circuit board manufactured. So I am going to switch back over to my document camera. I don't know if anybody can see the video now. Hopefully y'all can see my document camera. If you can't, somebody hit me on Teams for that, because I see Josh Tatum's face when I look at the video. Oh, okay. Let me try to change my video and then I'll change it back. Oh man, did I lose video or something? That's too bad. Well, live demo, something was gonna go wrong. Okay, here's what we're gonna do. Pause for a minute. I'm going to unhook and rehook my USB. Give me a second. Any better? Take it, but it's not working. Oh, maybe it is. Can y'all see that?
I can see it.
All right, fantastic. Okay, so now you're at a point where we want to solder this thing together, make sure it works. And so in that kit, we've got the circuit board. And so by the way, as we're soldering this thing, I wasn't even trying to be subliminal about this. I put the Fulcrum logo on the front and the back. So the whole time you're soldering on this thing, you were looking at the Fulcrum logo. So sorry about that. So what we got is we got the board itself. We've got the power connector. We've got all the resistors. I'm going to pull those off of my breadboard. And we'll just do a tiny bit of soldering on here just to kind of walk through some of the steps. So here's a whole bunch of LEDs. Got that. Okay, so that's all the stuff that we need to make this thing work. And so once again, if you look at your LED, you've got a long end that's positive and you got a shorter end that's negative. And if you look at the circuit board itself, every one of those LEDs has a little plus next to the positive side. So what you'd want to do is run your positive side through there. And we'll just do this really quick, run it through there. And I don't know how other people do it, but I always like to kind of put them through there and then bend them just a little bit so that they'll stay in place. It's just kind of one of my little things I like to do. And so we're going to grab a resistor. Got to straighten these up. I got them all crooked. So we'll grab a resistor, put it in. Yeah, see, now it's all bent, so I got to really pull it through. Oh, yeah. Screw this thing all up. Let's see if we can get it in there. I made a mess of this. All right, there we go. So we got our resistor in, kind of the same thing. We'll bend those back just to kind of hold them in place. And then we would want to solder those together. And so kind of what I'll show you is the solder that I like to use is in this tube. I know there's a lot of different ways to buy solder. I have another roll of it right here. It's the same kind of solder, but I totally prefer getting it in these tubes because you can just pull it through the end. And then now I just have to hold this thing and hold that thing. It's so much simpler to use as I'm doing solder. And this is, by the way, when you're buying solder, what you're looking for is rosin core solder. You can see that. But rosin core solder. And then they make different sizes of it. And so since these are pretty small little pin connectors, I've chosen a really small width of solder here. And so let's just do it. So when you're soldering, I think one of the number one things here is that we don't, sorry, we're in this weird. In hindsight, I chose a very reflective color to put on here. But one of the number one things is when you're soldering, you know, you don't want to touch the soldering iron to the component for a very long time because you're getting a lot of heat transfer. And so if you touch it there too long, you will transfer too much heat into the LED or into the resistor and actually cause it to burn out. So we don't want that to happen. So typically we're going to get in there just a few seconds and we're done. So I touch the soldering iron to it just long enough to heat it up and transfer the heat from the soldering iron to the component. And then I put my solder in there and it solders it. So we'll do that. Oops. Boop. There we go. Same here. Very quickly, just for a few seconds. Boop, boop, boop. There we go. So very quickly, I got those 4 connected. I'm not going to do all of these here today. I just wanted to kind of demo soldering it on. But one thing I do want to point out is that on the board, you'll look at this little part right here. You'll notice that I didn't label it positive or negative. Kind of messed that up a little bit. But obviously, the way that you want to solder this onto the board is with the holes for the wires facing out so that you can put the wires into it from this direction right here. So you would put it onto the board like that, flip it over, solder those 2 points onto there, and you'd be good to go. And then as far as like which one is positive, which one is negative, the one on the left is positive and the one on the right is negative. So just remember that if you're doing this at home, that's how you would do that. So usually like what I'll do is I'll put all my components through and just solder them like all at once, just to kind of go quickly. And at the end, you've got all these little things hanging off. It's really great to have a little pair of snippers like these. These are angled, so it lets you get down right onto the board, and you can clip your wires off and just clean everything up. Real simple. You just do that. And so from there, you would just wash and repeat and do all of your LEDs, all of your resistors. You would solder that thing on. And then when you're done, hold on, you'll end up with something that looks like this, where all your LEDs are on there, all of your resistors are on there, and then you screw your, if you have a tiny little screwdriver, which I do, I have these little guys, you just unscrew these, you literally jam your wires into there, screw them back down, and you're good to go. And then all you need is a 9-volt battery. So you notice that there's no 9-volt battery included in your kit. Sorry about that. I blew all the money on those other kits and all the rest of the stuff. I didn't have enough money left in the budget for a $2 battery, so I apologize for that. But you should have a 9-volt battery laying around the house. So theoretically, if I plug this in, it should work. There we go. We have light. So that is it. That is the entire process, start to finish, how you would design and create your own circuit boards. And so what I will end with, for me, is kind of the why, like why did I learn how to do this in the first place? If you were in my 3D printing session that we did earlier, I talked about really kind of getting involved in this stuff with Microsoft Flight Simulator way back in 2020 when it came out, and decided that I wanted to build my own flight control panels, and I chose to do it with a G1000. And so I designed my own custom circuit board for that. I'll just put it here, you can see it. The actual circuit board, let's show you that, hold on. The actual circuit board is just like this. So some of the things you notice here, you know, we built a circuit board that was triangular, but you can also build circuit boards that have cutouts. So for me, I've got some rotary encoders that I've got to put into the flight simulator. So I needed to have room for them on the board, so I just did a little cutout. So you can see very custom shapes. So you're really not limited to anything like square or rectangular. You can do all kinds of custom shapes there. So this is the raw board as it came from the manufacturer. I chose white for the silk screen. Don't know why, just did. And so then when you solder all the components on, it ends up looking like something like this thing. And so this is basically a combination of designing and building your own circuit boards, but it's also a combination of 3D printing. So all of these buttons on here were 3D printed, and then the faceplate for the buttons were cut from 1/8 inch white acrylic plastic sheets that I spray painted black, and then I cut them out with a laser cutter, and then you engrave them. So the whole idea of this is that if I plug this in, let's just see if this works. If I plug this into my breadboard over here that had power applied to it, theoretically, it would light up. And so you can kind of see where we're getting that, the backlight of that. So that was really my motivation. That was what got me involved in electronics. 4 years ago, I knew zero of this. I have no degree in electronics. I literally figured all this out just by trial and error, watching YouTube videos, talking to other people. So I guess the moral of the story is, if I can do this, absolutely any one of you can do this. So that pretty much wraps it up for today, I think. If I would say if there's questions, I'm probably not an expert enough to answer those questions, but I can give it a shot. I do work with someone here who has a degree in mechanical engineering and physics, and he's extremely good at electronics. We could get you answers if you need them. All right, so I'll stay on the line just a few more minutes, but for the most part, we're done. I appreciate everybody joining. And I encourage you all to try this out yourself. I had two open LEDs and, oh, I'm sorry, Jim. I don't know what random more means. Random more means it is working. Maybe my camera's working. Okay. All right, since no more questions, like I said, thanks for joining. Appreciate y'all's time today. I'm gonna end the session now. So thank you, everybody.